Okay, here's warm-up 7 PT. We're going to be solving some rational equations. Okay, so one way to handle this problem is to get common denominators. I could multiply the left by x minus 2 over x minus 2 and the right by x plus 2 over x plus 2. But I don't want to do that because I've just got two fractions that are equal to each other, and when that's the case, the cross products are going to be equal, so this is going to be easier. Okay, so I'm going to take 3 times the quantity x minus 2, don't forget the parentheses there, and then 5 times the quantity x plus 2, don't forget the parentheses, because then I'm going to distribute. Okay, and continue solving for x. So let's subtract 3x here. Subtract 10. And divide by 2, and x is going to equal negative 8. Okay. All right. Next up. Okay. Now this is a little different. I can't cross multiply because I've got more than 2 fractions. I don't just have 2 fractions equal to each other, right? There's a third piece in the picture there. All right. So now I am going to need a common denominator. That's one way to do it. 8x would be a good common denominator. Okay. So I could multiply this first fraction by 2 over 2, and that one by x over x, and that one by 2 over 2. And that's totally fine. There's another way to do this, which would be to multiply each fraction by the common denominator, and that should clear out all of the fractions. So that's what I'm going to do. So I'm kind of thinking in my head, okay, my lowest common denominator would be 8x. Okay, or you could kind of break this apart in different ways. You could think of this as 8 times x like that, or 2 times 4 times x, or even 2 times 2 times x. It's 2 times 2 times 2 times x, I mean. Okay, so those are all equivalent, right? Those are all the common denominator. And I'm just going to use what suits me on each one of these. So I'm going to space these fractions out a little bit. Kind of like I did on this problem over here. Okay, and then let's start, so going to multiply by the lowest common denominator here, and I'm going to use, I think I'm going to use this version, just because, or I'm going to write 8x like that, because then it'll make it easy to cancel out the 4x's, right? I'm going to use this version on this middle fraction, because then I can just cancel out the 8's, okay? And then let's see, I'll use a kind of, well, I'll use this same thing on this last fraction. So I'm multiplying the whole equation by 8x, right? And yeah, I'm not multiplying the denominators because if I multiply this first fraction by 2, let's say, I wouldn't multiply it by 2 over 2. I'm just multiplying everything by 8x, okay? And now we should be able to cancel away fractions. So those pieces are gone, right? These pieces are gone. These pieces are gone. Let's see what we got left. So this first fraction, all I have left is 2 times 3. Here all I have left is an x, and then the last piece, all I have is 14. And then just subtract 6, and x will equal 8. Okay. Kind of always when I'm getting solutions, I'm just keeping an eye and thinking, if I plug this in the original equation, that doesn't give me a 0 denominator, right? So this isn't an extraneous solution. Same thing with that one. That doesn't give me a 0 denominator, but I'm keeping that in the back of my head. Okay. Now this next one's a little trickier. So my lowest common denominator, well, these both have x plus 2's, but that one doesn't. So what I'm thinking of the lowest common denominator, I'd have to multiply those two denominators together. So you can think of it as x squared plus 2x, or like that. I think it's easier to leave it factored like that because it's going to work nicely with reducing these. Okay. So again, I'm multiplying each fraction by this LCD, and that's why I have it spaced out, to give myself a little space for that. And then let's start reducing. Okay, and then I'm just going to see what's left. So this first fraction, here's what's left here. X plus 1 times x. My second fraction, all that's left is x plus 2. And the third fraction on the right side of the, I'm going to have 2x plus 1 times x. Okay, and then let's start cleaning this up. So I'll distribute here. And I'll distribute here as well. Okay, now let's see, this is going to be 2x squared plus 2. Okay, I'm going to actually pull everything to the right side of the equation just because I'd rather keep the x squared terms positive. So I could subtract either one of these from both sides, but I'd rather do this. So now I've got 2x plus 2 equals x squared plus x. Okay, I'll subtract 2x from both sides. And then subtract 2. I'm not going to write it in. Yeah, when I subtract 2, it's just going to be this. Okay. All right, got this a lot simpler. I still haven't solved anything though, right? Solving means I got to find the x values that would work in the original equation. So now I'm going to factor if I can. If I can't factor, I could always complete the square or quadratic formula, but I think this one is going to be factorable. Let's see. I'm looking for two numbers that add to -1 and the same two numbers multiply to -2. So how about that combo, right? So this is going to factor into x plus 1 times x minus 2. And then I'll use the zero product property. So x could equal -1. Or x could equal 2. Okay? Okay. All right. And then I'm checking those answers to see if either one of them would be extraneous. I was kind of expecting one of them to be extraneous, but looks like they're not, right? If I plug in a positive 2 in the original equation, that's okay into any of those fractions, and same with a -1. All right, that's it, and I'll see you next time.